This is Algebra 2, and it's lessons 3.1 and 3.2. We're going to talk about relations and functions. So lesson 3.1 and 3.2, relations and functions. So 3.1, relations. Well, first off, let's start with a review of a Cartesian plane. Cartesian plane. All right, and this should be familiar to everyone, but I just want to make sure that we're all thinking correctly. Alright, so the Cartesian plane is made up of two axes. You have the horizontal axis called the x-axis, and then you have the vertical axis or the y-axis. So horizontal axis and vertical axis, and just like number lines on the horizontal axis, positive numbers go right and negative numbers go left. And on the vertical axis, of course, positive numbers go up and negative numbers go down. Alright, so the center point of the Cartesian plane is called the origin. Right, origin is that center point. That's an I there, origin. Right, and the coordinates of the origin are 0, 0. Remember, points are located in the Cartesian plane by their coordinates. For example, if we had a point right here, the coordinates of that point would be first the horizontal coordinate or the x coordinate, and in this case it's a 2, and then the vertical coordinate or the y coordinate, in this case it's a negative 4, right? So the coordinates of that point are 2, negative 4. And points are located in the Cartesian plane by their coordinates. Okay, so we've got Cartesian plane, you got an x-axis, a y-axis, 0, 0 is the origin, and then points are located in the plane by their coordinates. Again, remember, the first coordinate always corresponds to the x, and the second coordinate to the y. Alphabetical order should have a problem there. All right, the axes also break up the Cartesian plane into 4 quarters or quadrants. 4 quadrants. All right, and so the first quadrant is in the upper right, and we use Roman numerals for our quadrants, so that's quadrant number 1, and quad 2, 3, and 4 would follow not clockwise but counterclockwise. So quad 2 is in the upper left. Just by way of explanation, the reason for that is if you think about an angle in standard position, you don't need to put this in your notes, has its initial ray along the positive x-axis. That's what I've just drawn there. And then as this angle opens up, you can see that would be approximately a 60-degree angle, maybe something like that. It's in quad 1. Well, let's go further. Let's go to about a 135-degree angle. Well, there's a 135-degree angle, and you can see now we're in quad 2. Go past 180, maybe I don't know, something like a 240-degree angle would be something like that. Notice now we would be in what is called quadrant 3. And if you were to keep going, I don't know, this is probably about a 340-degree angle, and you would be in quadrant 4. And so that's the concept and the reasoning behind these quadrants. So quad 3 is down here in the bottom left, and quad 4 is here in the bottom right. Okay, so just basics of a Cartesian plane. Number 2, what is a relation? So number 2, relation. It's simply this, it's a set of ordered pairs. A set of, and I'm going to write ordered pairs in red here, a set of ordered pairs. That's all relation is, it's a set of pairs. Everything has to be paired up for a relation. And so just as I showed you a moment ago with a point and its x and y coordinates, that's really the concept. So for example, let's suppose we had set A, so we'll go capital A equals brace, right, and then we're going to put in here some pairs. I'm going to go 0, 2, and then I'm going to go negative 2, 4, and then I'm going to go -3, -2. All right, so what we have here is a relation. Why is it a relation? Because we have these sets of pairs, right? If you take a look, we've got the 0 is paired up with the 2. We've got the -2 is paired up with the 4. And we've got the -3 is paired up with the -2. Everything is paired up, and therefore this is a relation. If you had 5 pairs and then one that's not a pair, it would not be a relation. Everything has to be paired up. Everything has to be paired up if it's going to be a relation. Of course, you can graph this relation in a Cartesian plane by simply plotting the points, right? Remember, each first coordinate is the x coordinate, and each second coordinate is the y coordinate. Right, so that first point has an x coordinate of 0, y coordinate of 2, would be right there. Second point, x coordinate -2, y coordinate 4 would be right there. And the third one, x coordinate of -3, y coordinate of -2 would be right there. And that would be the graph of the function in a Cartesian plane. The graph of the function in a Cartesian plane. We can also do mappings. So, mappings. A mapping is another way of representing a relationship. All right, so let's do set B here equals brace. Let's go with the pairs 1, 3, -1, 2, 3, 2, and 1, 5. 1, 3, -1, 2, 3, 2, and 1, 5. Okay, so what a mapping is, basically use a circle graph, and these will look like ovals. And so I'm going to have an oval here, and another oval next to it here. And just to refresh your memory, the first oval is the domain. The domain are all the x values. The second oval is the range. And the range are all the y values, right? So again, if I go through and mark here, that's an x, that's an x, that's an x, and that's an x, and all the second ones are y's, right? All the second ones are y's. Okay, so it's best to put the numbers in order, so I'm going to start listing the x's. So I list the -1 for this one right here, right? And then I've got a 1 for that one there. Now notice there's a 1 here as well, but you don't list it twice. 1 is 1, it's only in there once, you only need it once. Okay, so we got the 1, and then we also have the 3 right there, right? So -1, 1, 3, and then we go through and we list the ones of the range. And so if we were to list here, I'm going to do them in the order that they're listed. So I'm going to do 2 here, and then 3, and then 5, right? 2, 3, 5. Right, the last thing you want to do in your circle graph is you want to actually do the mapping. The mapping are arrows from the domain to its range. So -1 is mapped to 2. So we get an arrow from the -1 to the 2. It just shows the pairs. That's all you're doing here. All right. 1 is mapped to 3, but 1 is also mapped to 5. Right? And then finally 3 is mapped to 2. All right. So that's called mapping. It's showing the associations of the x coordinate with its associated y. Okay, mappings. And so again, if you were to list the domain, sometimes we'll use a capital D for the domain. It's -1, 1, and 3, right? All the possible x values. If you were to list the range, it would be all the possible y values. Again, you wouldn't repeat anything twice because you've got it covered by listing it once, right? Domain and the range. All right, that's really lesson 3.1, just a lot of review, and that's why we're just going to go quickly there and go through that and get going. All right, 3.2 functions. Functions. Algebra 2 and above has a lot to do with functions, and so we need to make sure that we are aware of what a function is. What is a function? It's a relation where every first element is mapped to only one second element. Is mapped to only one second element. Where every first element is mapped to only one second element, excuse me. So that's what we're talking about here. Functions, every first element is mapped to only one second element. In other words, the first element there's only one pair, one point that involves any first element. All right. So let me give you a couple examples and I'll explain this, and these are pretty simplistic here. So number one, we'll just do examples here. All right, so A, let's go set T equals brace. All right, now let's put in these pairs, 1, 4, 1, 4, and then we'll go 2, 5, and then we'll go 3, 5. 1, 4, 2, 5, 3, 5. Okay, notice any given X has only one Y. I like to put it this way. If you think of it in boys and girls, first one's the guy, second one's the girl. No guy can date two girls. That's the aspect of a function. No guy can date two girls. So if you look at it, guy number 1 is dating girl 4. Okay. Guy number 2 is dating girl 5. Guy number 3 is also dating girl 5, but that's not a problem because guy 3 is only dating one girl and guy 2 is only dating one girl. Okay. So a girl can date two guys, but a guy cannot date two girls. I'll explain the reasoning behind that in just a moment, but that's a function, right? An example of a function. And you can have all kinds of different pairs. It really doesn't matter as long as no first element is listed more than once. B here, this one is not a function. Not a function. So here's an example of something that's not. Let's go capital V equals brace. Let's go 1, 6, 0, 3, 1, 4, 2, 11. And we'll close it with a brace. So you got the pairs 1, 6, 0, 3, 1, 4, and 2, 11. So notice our problem here. Guy 1 is dating girl 6, but guy 1 is also dating girl 4. This is not a function. Okay. The first element is mapped to more than one second element, right? So 1 has both 6 and 4. And it doesn't matter if there's 2, 3, 4, 5 times that happens. If it happens once, it's not a function. And here's the reality of it. Think about a computer. Think about input and output. So a computer, so you input something on the keyboard and the computer is going to output something. Well, we have a problem now if we don't have a function. Because if this were the computer, if you inputted the 0, the computer has no problem. It will output a 3. It knows what to do. If you input a 2, the computer has no problem. It knows what to output. It will output an 11. But what happens when the input is a 1? Now the computer all of a sudden says, well, what do I give you? I don't know which one. Do you want the 6? Do you want the 4? I don't know. Both of them go with that 1. I don't know what to do. And that's the issue here with the function. Any input must give a definite output. Did you hear that? Any input must give a distinct or definite output. Okay, that's the idea of a function. All right, so any first element is mapped to only one second element. You mentioned a few terms here. I've already mentioned domain and range a minute ago. So in that, I need to get a few more aspects in here. And let's just do an example here of a function. So we'll do function A equals brace. Let's go negative 1, 1. Let's go to point negative 2, 2. And let's go to point 3, 5. Negative 1, 1, negative 2, 2, and 3, 5. Okay, so don't forget the negative 1 is an x, the negative 2 is an x, and the 3 is an x. And the 1 here is a y, the 2 is a y, and the 5 is a y, right? Okay, so just some terminology. All x, or sorry, not all, but each x value is called and I don't know if you guys remember this from Algebra 1, but it's an abscissa, A-B-S-C-I-S-S-A. Each x value is an abscissa. So the negative 1 is an abscissa, right? Right there. The negative 2 is an abscissa, and the 3 is an abscissa. Each one is an abscissa. So the negative 1 is an abscissa, the negative 2 is an abscissa, and the negative 3 is an abscissa. B. Each y value is called an ordinate. Ordinate. Ordinate, just take off the co from coordinate, or the c actually from coordinate, and you get ordinate. So each y value is called the ordinate, or you could also call it the image. You'll see it both ways. So ordinate or image. So if you look back at set A, 1's an ordinate or image, 2's an ordinate or image, and 3 is an ordinate or image, right? Ordinate or image. Right? So every x value is called an abscissa. Every y value is called the ordinate or image. C, the x variable is the independent variable. Independent variable. And the y variable is the dependent variable. And the y is the dependent variable. Basically, that aspect is simply this. Normally, we choose arbitrary values for x to determine what the y is. You'll see that in just a little bit as I refresh your memory on those kinds of things in functional notation. But just remember, the x variable is considered the independent variable, and the y variable is considered the dependent variable. Number 3, functional notation. Oh, sorry about that. Functional notation. Functional notation. Alright, don't make a big deal out of functional notation. It is simply a means of trying to, it's just a different way of representing a function. Alright, so I'm going to use my red here and go little, that's lowercase f with parentheses x. And then I'm going to have it equal 5x minus 3. This is functional notation. And the functional notation is the aspect of the f of x. Alright, if you would read this, it would be a function of x equals 5x minus 3. A function of x equals 5x minus 3. If you were going to say it in shorthand, and normally people do, you would say f of x. F of x. Okay? So this part here is f of x. Is again, that's short for a function of x. F of x equals 5x minus 3. Functional notation. And the key here is this is the value to input for the independent variable. the value to input for the independent variable. The value to input for the independent variable. You'll see that in just a moment, right? The value to input for an independent variable. But listen, you got to know functional notation. You got to know functional notation. So make sure you understand functional notation. At times you'll be asked to put something into functional notation. So how do you put something into functional notation? Okay. To put into functional notation. I'm just going to abbreviate there. All right, it's pretty simplistic. You just have a couple things you have to do. Solve the equation for y. So you're going to solve for the y variable, the dependent variable. And then number two, replace y. Replace y. You're doing a substitution move here with f of x. And that's all you need to do. All right. Solve the equation for y. Replace y with f of x. Let's do an example here. And we'll just keep it simplistic here. Let's suppose we had 3x plus 2y equals 8. 3x plus 2y equals 8. So again, this is Algebra 2, and normally you're just going to move things quickly, but just for way of explanation, I'll show, right, we're going to add a negative 3x to both sides to move the 3x. I hate when I do that. So we end up with 2y equals negative 3x plus 8, right? And so now there's two ways to proceed. You can either multiply both sides by 1/2 or divide both sides by 2. So I'm going to do it both ways just to refresh your memory. Not sure which way you prefer. So again, I like to multiply both sides by 1/2. But again, this is Algebra 2, and we can do a lot of this in our head. In this case, the 2's divide out. We're going to distribute this 1/2, right? So here we end up with y equals negative 3x over 2, or negative 3/2 x plus 4. Okay. And so I'll finish that off in a minute. Let's go to the right-hand side and get to that point as well. So again, here, if you're going to do this method, you're going to divide both sides by 2. Okay, so then you got to remember that is a negative 3x over 2 plus an 8 divided by 2 is 4. And notice, of course, we end up in the same place. All right, well, don't forget the last step. The last step is replace y with f of x, right? That's that last step. So where the y is, we've got to replace that with f of x. Again, that can be 3/2 x. And now we've put that into functional notation. Right? Don't miss this. You really do need to know this. And students can tend to forget it. So just don't forget it. How to put a function, or how to put an equation in a functional notation. Okay. All right, let's move on here. All right, so C, still underneath functional notation. All right, what's the real value in something like this? The real value is to let you know exactly what to put in for the independent variable. Here's what I mean. We're going to do it by way of examples. You're going to have something like this. F of 2 equals, and then you're going to have whatever it equals. Let's go x squared minus 3x plus 4. Okay, so by us giving you this problem, instead of saying this, all right, solve the equation y equals x squared minus 3x plus 4 if the x value equals 2. That's a lot of words. And instead we can just say f of 2 equals. Therefore, then you would know to substitute that 2 into every place where the independent variable is. So we're going to substitute a 2 in there, and we're going to substitute a 2 in there, right? All right, so what do we end up with? 4 minus 6 is a negative 2. Negative 2 and 4 is 2, right? And f of 2 equals 2. Now, what did we find? Remember, this is the x value. This is the y value. We have just found the pair 2, 2, or the point 2, 2. And so if you input a 2 with this function, what do you output? You output a 2. Let's do another example here. So what if you had f of negative 2 equals negative x squared minus x minus 4? All right, be careful. Be careful here. You've got a negative value for the independent variable, and you've got a couple negatives here you have to navigate. What I always do is simply this, and it's foolproof. If you'll just simply write what you have and where the variable is, put a parentheses, right? So I got that negative sign, then a parentheses, and then it's squared. I got another negative sign, and then where the x is in a parentheses, and then the negative 4. And now I'm going to take my value for the independent variable, and I'm sticking in those parentheses. If you'll do it this way, you'll be in much better shape. All right, just for clarity's sake, negative 2 times negative 2 is a positive 4, right? But then you've got this negative in front. But be careful there. Students mess these up. All right, the second one is clearly negative, and negative 2 is a positive 2 minus 4. And now we can finish this thing up. And so we end up with what? A negative 6. So f of negative 2 equals negative 6. And what's our pair here? Our pair is negative 2, negative 6, right? The x is a negative 2. If you input a negative 2, you output a negative 6. If you input a negative 2, you output a negative 6. All right, one more here. You could be given something like this. G of r equals 7 minus 5r. Oh, I'm sorry. 7 minus 5q plus q squared. Okay, well again, this is what we need to put in for where the variables are in the second part. So where this q is, we got to put an r, and where this q is, we have to put an r. Don't let the fact that you got variables scare you. Just simply sub in. Where that first q is, I put an r, and where that second q is, I put an r. And that's all you can do with that. You can't go any further, right? That's the situation. It's as far as you can go, and that is where you would leave it. Okay. All right. D here. D, finding pairs. Finding pairs. So what they'll do is something like this. They'll say evaluate f of x equals 3x plus 2 for the domain, and then they'll list it in set notation. So brace negative 3, 4, 6. So evaluate f of x equals 3x plus 2 for the domain negative 3, 4, 6. Hey, all this is 3 problems. First, put a negative 3 in. Second, put a 4 in. Third, put a 6 in. That's all that's here. So it's really 3 problems in one. So first off, I'm going to do f of negative 3, right? And where the x is, I'm going to sub in my negative 3. So finish this off. F of negative 3 equals negative 7, right? Negative 9 plus 2. Second time, we're doing now the 4, f of 4. Again, where the variable is, I'm going to sub in that 4. Right? So we got 12 plus 2, and that's a 14. So we got the pair 4, 14. And on the third one, we're going to do f of 6. So again, I'm back to this 3x plus 2, right, each time. And where the x is, I'm putting in the 6. And now we've got 18 plus 2, or 20, right? So the last pair is 6, 20. So you end up with these pairs. -3 is mapped to -7, 4 is mapped to 14, 6 is mapped to 20. Again, the x's are the independent variables, or the independent values, the abscissas, and the ordinates are the y's. Okay. Number 4, linear functions. Linear functions. A linear function is simplistic. It's a graph where the function is a line, right? Part of the word linear is line. So a function where the graph is, I'll finish in red, a line. Hence the word linear. A graph where the function where the graph is a line. So for example, usually they'll look something like this: y equals 7x plus 1. That is a linear function. How would I know this is a linear function? All right, there's two ways. First off, it's linear because my variables are to the first power. See, first power, first power. My variables have to be to the first power for it to be linear. And then it's a function because there are two different variables. There's an x, there's a y and an x variable. Okay? So it's a linear function. And there's all kinds of different forms. Here's another example. I mean, it could be in this form, right? 3x minus 5z equals 11. Okay, is this a linear function? Yes, it is a linear function. It's linear because my x variable is to the first power and my z variable is to the first power. Okay, so it meets that criteria. So it's linear, and it's a function because there are two different variables, an x and a z. The only thing that would ruin it is if the x were times the z. Then that's a whole different ball game. But as long as they're not multiplied together, then it is a linear function. Okay, with linear function comes the idea of standard form. Standard form. And this is just something that everyone should have memorized, and it goes like this. A, and that A is really a number, represents a number. Then I'm going to use my red here for x. AX plus B, and I'm going to go to green here, BY equals C. Okay, our variables are the x and y. A, B, and C are numbers. They're just simply numbers. So A, B, and C are numbers. The x and the y are the variables. And so that is standard form. An example of standard form would be something like this. 7x minus 9y equals -15. All right, so just a quick primer on standard form. The variables are on the left, right? The non-variable numbers on the right. Okay, checks. The variables are in alphabetical order. Yes. The front variable is positive. Yes. And there are no fractions. Yes. That's standard form. All right, let me do it one more time for you. Variables on the left, number on the right. Okay, check. What else? Variables in alphabetical order. Yes, correct. What else? Front variable is positive. Yes. What else? No fractions. No fractions, no fractions. Okay. So that's standard form. Standard form. All right, number 5. Number 5, graphing linear functions. Graphing linear functions. All right, I'm trying to hurry a little bit here. I have morning devotions in just a couple minutes, and I got to get through this. All right, this is a key statement. I would asterisk this and get it in your brain. Anything can be graphed using an XY chart. Anything can be graphed using an XY chart. Anything can be graphed using an XY chart. Okay. All right, so I'd like to do 2 examples here, but I think I'm only going to have time for 1. Anything can be graphed using an XY chart. What we need to do is to graph linear functions is we need to find the pairs. So let's suppose we had this 3x plus y equals 6. Okay, it's easiest if we'll solve the function for y. So let's add a negative 3x to both sides, and you get y equals negative 3x plus 6. Now we're ready for our XY chart. All an XY chart is this. You choose values for x and find the corresponding value for y. So what if I used a 0 for x? So remember, y is going to be negative 3. Put in that 0 for the x plus 6. So y is a 6. Okay. Next I'm going to use 1. And so again, now where the x is, I'm putting in 1. And I get a 3. And third here, I'm going to use 2. So again, where the x is, I put in a 2. And I get a 0. Now I'm ready to graph this. So I need a Cartesian plane. Alright, got my Cartesian plane. All I do is plot the points. So I go 0, 6, plot that point. And I go 1, 3, and plot that point. And you always want to do 3 points because here's the reality. Any 2 points will give you a straight line. But if all 3 line up, you should be confident that you are correct in graphing your line. Now this is a linear function, and every point along this line solves this function. So you need a line through those points and arrows on both ends. It goes on forever in that direction. Okay? And so a linear function. Remember, each point along the line are the xy pair that make the function true. Every point along the line are the xy pair that make the function true. And I've got to hurry. All right, the last thing is number 6, recognizing functions. Recognizing functions. And this is called the vertical line test. Okay, it's real simple. If you can find a vertical line that intersects more than 1 point, it's not a function. If you can find a vertical line that intersects more than 1 point, it's not a function. For example, suppose we have these points in this Cartesian plane. Well, there's a bunch of vertical lines that only hit 1 point. No points, 1 point, 1 point. But look at this vertical line. Hits 2 points. This is where it failed. So this is not a function. Not a function. Now it can be points. It could be other things. Here's a line. Again, that's a bunch of points. But look, no matter what vertical line you choose, you only hit 1 point. This is a function. Is a function. And again, they can look all different ways. We're going to do parabolas here, which look like that. But you know what? No matter what vertical line you pick, it's only going to hit 1 point. So this is a function. That's the vertical line test. All right, I got to run.